It was the biggest reptile to walk the Earth since Tyrannosaurus Rex. 1/4 of a ton of cold-blooded killing power.
Megalania was one of the greatest predators of all time.
For more than 1 million years, this giant ruled a continent. In a world of hot-blooded mammals, a monstrous reptile owned the land.
There would have been nothing alive at that point in time that could have taken it out.
And there are rumors it still crawls the earth today.
Imagine something as big and powerful as a Nile crocodile, but walking around on the land.
The terror of the outback, Megalania, the giant lizard resurrected. Australia, isolated by oceans on all sides. This island continent has provided a unique environment for evolutionary experiments for millions of years. For most of us, the image we have of the Australian outback is that of a desolate place, populated by small and cute pouched mammals such as kangaroos and koalas. The biggest land predator, the dingo, is no larger than the average dog. But Pleistocene Australia 1.5 million years ago was a very different place. The continent teemed with enormous marsupials known as megafauna, which were anything but cute. Imagine a monster kangaroo that towered over 2 meters in height and weighed more than 225 kilograms. The biggest kangaroo that ever lived. Meet Procoptodon. Imagine a 2.5 meter long wombat that weighed more than 2,700 kilograms. Meet Diprotodon. And feasting on these huge creatures, a gigantic meat-eating lizard you wouldn't want to meet, Megalania.
Megalania was one of the greatest predators of all time. It ranks with Tyrannosaurus Rex and the great white shark.
This extinct monster would have dwarfed its modern relatives, the monitor lizards, such as the Komodo dragon, the largest lizard alive today.
Megalania was a huge lizard. Hey, when we think of lizards, we think of things the size of a little iguana. But Megalania was a lizard that was bigger than the modern-day Komodo dragon. It was one of the largest terrestrial predators of its time. This is an animal that was muscle and bone. This was a very strong animal. And if you look at the construction of its jaws, it had jaws that could lock around pretty much any one of its prey items. So if it got a hold of something, it wasn't going to let go. I would have been more scared of Megalania than I probably would have been of an African lion.
Monitor lizards are absolute machines. They've got these incredibly tough scales on covering their body, where the scales actually have chunks of bone inside of them, and this is particularly the case for Komodo dragon and lace monitor, and therefore Megalania would have been the same.
Scientists estimate that Megalania grew over 6 meters in length and weighed more than 2/3 of a ton. It's clear that this giant lizard was indeed a mega monster. And Megalania has earned Australia an unusual distinction.
Australia was unique that after the age of the dinosaurs, it was the only continent that remained dominated by reptiles. Most of the other continents were dominated by mammals. This could be in part by the fact that not only is Australia very isolated, but it's also very, very hot.
Why did reptiles prevail in this one area when mammals ruled everywhere else? The rise of mammals was the result of a global catastrophe. 65 million years ago, a huge asteroid slammed into Earth, killing off the giant reptiles we know as dinosaurs. With dinosaurs out of the way, mammals evolved into the dominant species. Ultimately, they would rule the planet with one notable exception: Australia. Here, evolution took a different route.
Australia has often been referred to as a natural laboratory because although it's a big place, it's also isolated like a big island. So if something has a chance of experimenting there, it's often going to take place there.
Dr. Scott Hucknall is the world's leading Megalania researcher. He has spent years piecing together hundreds of fossil bits to reconstruct this monster's skeleton.
150 years ago, Megalania was only known from a single bone, a piece of the backbone, a vertebra. Over that 150 years, museums across Australia have found more and more pieces of that skeleton, except for one, the skull. Skull pieces have come into museums over the last 20 years. And so what I've done in this study is bring together all those pieces of the skull and reconstruct the head of Megalania for the first time. When you take all the small pieces of the skull and you put them together, you realise one really fundamental thing about it. It was solid. A solid block full of teeth, sort of like a crocodile. So you can imagine an animal that was really, really strong with a very, very robust head and would use that to kill its prey.
What was it about Megalania that made it such a deadly predator? And how did this giant lizard earn the nickname Giant Ripper?
The solid skull of Megalania is perfectly adapted for an animal that attacks, grips, tears huge chunks of flesh out of its prey, leaving them to bleed to death.
The teeth of any predator are the key to understanding how it kills. Some, like those of saber-toothed cats, were designed to pierce and slice. T-Rex's teeth were designed to crush armor and bone. Megalania's teeth both gripped and ripped.
This is a fossilized jaw of Megalania, and as you can see, it has these amazing pointed teeth, conical at the base, so they're very firm in the jaw. It would use these teeth to puncture its prey and ripped massive chunks out of it. Each of Megalania's teeth were armed with a fine series of serrations, just like a steak knife. What's important about these teeth is that their serrations are on the back, which allows the tooth to slice through the flesh when Megalania is pulling back on its prey. You can imagine what a huge hole that would leave in the side of its prey as blood starts gushing out of the animal with such a huge open wound.
And Megalania had a special adaptation that made its bite even deadlier than its modern-day relatives.
This is a skull from a modern-day monitor lizard. You'll notice that it has a straight tooth line going all the way around to the front. This is common amongst all modern-day monitors. So that makes Megalania unique, because if you have a look at its jaw, its tooth line is upturned right up to the front of the snout. This allows Megalania to bite down on its prey and clamp it. And what this means is that it can puncture its prey and slice huge chunks of flesh, bigger than any monitor living today. A huge bite force, a huge bite diameter, massive blood loss.
Individually, each of these adaptations was a lethal weapon. All put into one beast, they made Megalania a killing machine. But the competition was also deadly. What gave Megalania the edge? Did it have a secret weapon? To answer these questions, we have to analyze its deadly weapons and investigate how a cold-blooded killer lizard was able to dominate more intelligent, warm-blooded mammals. lucky, giant 6-meter carnivorous lizards don't lurk in the meat section. Fortunately for us, this mega beast became extinct thousands of years ago. During the Pleistocene, however, Megalania was the apex predator of Australia, hunting and killing animals much larger and faster than itself. We know about its weapons, but how did this hyper-carnivore use them? And what was its hunting strategy? The few fossils of Megalania that have been found don't give scientists a lot of clues, so we must look to its modern relatives. Though there are no monitor lizards as big as Megalania today, they probably share a lot of traits with their giant ancestor. Brian Fry is a world authority on venomous snakes and lizards, and has worked close up and personal with different species of monitor lizards.
Monitor lizards are one of the ultimate predators. They have incredible senses. They have good sense of hearing, but they also have excellent sense of smell. They can smell rotting carrion from over a kilometer away, and they have great visual acuity as well.
In this hot environment, Fry is dressed for the chase. Despite its size, this lace monitor is Megalania's closest living relative. Very dangerous and an excellent hunter. But Megalania's bulk made it easy to spot from a distance, and the animals it preyed upon were always listening for danger.
If you're a prey animal, your best defense is to be alert, and the best way to be alert is with the hearing. So that's why a lot of mammals have very good hearing, that they can change the direction of the sensing, and they can detect a predator and then they bolt the opposite direction. They're more likely to survive. So obviously the slow and stupid are the first ones that get eaten.
If hearing is the key to survival for prey animals, how could a giant like Megalania get close enough to surprise its prey? To help us imagine how much noise Megalania would have made, we asked Dr. Fry to conduct an unusual experiment.
Well, you'll hear some glottal hissing as he's walking around.
All right, so maybe put it up near the throat.
Yeah, that'll work.
Fry and a member of our film crew temporarily attach a microphone to the lace monitor using removable tape.
Let's get that coat. Easy, easy. He's done. He's all ready to go.
Okay, good, because I'm bleeding.
Okay.
Then we let the lizard loose. It's obvious that this is no quiet hunter.
When you hear that lizard walking through the bush, it makes a lot of racket. Megalania would have made 10 times that noise.
Megalania simply wasn't built for stalking prey quietly. It had to find another way. But how could a 6-meter-long lizard even locate its prey without revealing itself? Once again, studying its modern relatives may give us a clue. Most lizards have excellent eyesight, but the sense they rely on most to find prey is smell. And monitor lizards in particular have a remarkable adaptation to enhance that specific faculty.
They have a very long snake-like tongue, which shows their close ancestry to snakes, and they use that to smell the air just like a snake would, and it's an extraordinarily sensitive detection device for them.
The scent of a prey animal consists of tiny particles that lift off the creature and float through the air. Some of them land on the lizard's tongue. When the lizard retracts its tongue, it actually analyzes where the particles came from. Because the tongue is forked, one side is slightly closer to the prey animal. More scent particles land on that side, and that helps the lizard home in on its target.
When they put their tongue out, they actually get it out in stereo, so they can detect left versus right by the tips of it and then help them orient on both directionality and distance.
But locating a prey animal is just the start. How could the giant lizard get close enough to kill? The answer? Ambush. It is the most efficient way to hunt, much less demanding than running down your food.
All predatory animals make a trade-off. Calories in or calories out. It all depends on how much energy you use versus how much food you get back in return.
But Megalania would have to stay out of sight, hiding behind bushes or in tall grass. It typically couldn't see its prey. So how would it know when to pounce? The mega monster had its own organic radar system. Megalania had an extraordinary supersensory mechanism that allowed it to visualize its world without actually seeing it. It's the same kind of system that crocodiles have, which enables them to sense the movements of fish in very murky waters. Like the crocodile, Megalania's jaws had a built-in motion detection system.
It sits there with its head on the ground, and it uses these sensory pits along the upper and lower jaw to actually sense the vibration from the prey coming along. Each one of these pits is a nerve ending, and it can tell almost 50 feet away whether the prey is big enough for it to bother to even attack.
Megalania would hide near waterholes and feeding areas where prey animals were likely to pass. Then it would simply wait for the telltale vibrations. But even with all these sensory advantages, for a cold-blooded reptile to capture hot-blooded mammals was still a challenge. And this lizard needed a lot of food. For example, the Komodo dragon eats up to 80% of its body weight in a single meal. At twice the size, Megalania would probably have needed to consume twice as much food. But what could provide a full-course meal for a quarter-ton super lizard? How about a 2-meter-tall, 225-kilogram kangaroo? And when these two creatures get into a fight, anything can happen. Scientists believe that Megalania became extinct thousands of years ago. But persistent rumors claim that a few of these giant carnivorous lizards still lurk in remote stretches of the Australian outback. Of course, there is no evidence that a 6-meter lizard is still out there today. Fortunately for us.
If Megalania were still around today, there would be a lot of dead people out there. Livestock would be in peril. The largest living varanid lizard today, Komodo dragons, eat goats. Those are small compared to Megalania. And so I would imagine something as big as Megalania would be taking down cattle.
During the Ice Age, this reptile was the apex predator in a land of giant mammals. So what was on the menu? On this isolated continent, marsupials had become the dominant mammals, and many of them were supersized, much larger than the pouched animals we know today. The biggest of the lot was Diprotodon. This 2,700-kilogram herbivore was like a monster wombat the size of a rhino, and its size was its best defense. And just like today, Australia was teeming with kangaroos. The only difference is the giant short-faced kangaroos weighed 225 kilograms and stood over 2 meters tall. They were able to grab foliage 3 meters off the ground, beyond the reach of other animals. This king-sized skippy was a prime prey object, but it wasn't an easy target.
Giant kangaroo isn't just meat on 4 legs. It would have been a formidable foe for any predator to attack.
These giant kangaroos were the mixed martial arts fighters of the outback. Like their modern counterparts, these extinct giants defended themselves by kicking with their powerful hind legs. They could disembowel an attacker using the claws on their feet.
This is the thigh bone of a modern grass-eating kangaroo. It's an animal that might have weighed in the order of 100 to 120 pounds. We can see when we compare that with the thigh bone of the giant kangaroo, just what a marked difference there is.
To bring down one of these giant critters, Megalania would have to lie in wait until it got close enough to ambush it. Then the huge lizard would rush forward, but the attack would bring it into range of the kangaroo's powerful back legs.
These giant kangaroos, they're not just going to shrink away or lie down and die. They're going to try and defend themselves. Like modern kangaroos, the animal will probably prop back on its tail, lashed out with those hind legs.
Megalania is far too sturdy to be killed by a kick. But the giant kangaroo only needs to stun the lizard to give itself time to escape. However, the monster-roo is slow to accelerate, making it extremely vulnerable until it gets up to speed.
Well, my money would definitely be on Megalania.
And although Megalania was big and bulky, it may not have been as slow as it looked. Modern monitor lizards are specially adapted as chase predators. They have a special technique that enables them to pump more air into their bodies while running. They expand their throats to draw in air, then contract it to force the air into their lungs. This natural supercharger pumps more oxygen into the monitor lizard's system, allowing it to sustain high speeds over long distances.
And what that means is that if they can see a prey item, they can run it down.
Megalania may well have shared this ability to accelerate quickly and keep going. All it needed was to get close enough to grab the tail of its prey.
This tail is integral to a kangaroo's movements, and if that were bitten by a Megalania, it would be in a lot of trouble.
It would try and hop away, bleed to death, Megalania would still have its meal.
Even with all its strengths, the giant kangaroo is no match for Megalania. But Megalania didn't have this bounty all to itself. There were other predators on the continent. And the most deadly was a bizarre creature called Thylacryleo carnifax, a marsupial lion. Despite its name, it was not a lion or even part of the cat family. This beast was actually a distant cousin to wombats and koalas, but definitely not cute and cuddly. Imagine an animal half the size of a tiger with the aggressive personality of a cornered possum.
The marsupial lion was Australia's largest mammalian predator, with slashing claws and grasping hands and blade-like teeth.
Fossil remains of the marsupial lion and its prey have been found all over the continent. But one place in southern Australia has become the El Dorado of Pleistocene epoch bones. Over the course of 500,000 years, thousands of animals fell into a labyrinth of underground caverns through sinkholes. Few of them ever got out. Known today as the Narrow Court Caves, this network of chambers is home to some of the richest fossil deposits on Earth, including the remains of several marsupial lions. Paleontologists, such as Dr. Liz Reed, have made some surprising discoveries about the special adaptations that made this unique animal such a deadly predator.
This is a 200,000-year-old fossil of the marsupial lion's hand, and it has special features that allow it to be a very effective predator. Large claws that it can use to slash and pierce prey, and an opposable thumb which allowed it to grasp and hold on with those massive claws.
The marsupial lion had unusually flexible forelimbs compared to other predators.
The bones of the forelimb of the marsupial lion reflect its strength and flexibility. If we look at the elbow, you can see a large range of movement in the joint, big wide joint, wide bones, lots of power. And unlike a lot of other animals, including predators that are restricted to this kind of movement, the marsupial lion could reach in and grab prey and hold it to its body, allowing the mouth to then deliver the killing blow.
500,000 years after they were made, the marsupial lion's tooth marks can be seen on the fossilized skeleton of one of its victims.
On this bone, you can actually see the slice marks produced by this big blade tooth of the marsupial lion. So as it's devouring its prey, it works at where the muscle attaches to the bone and slices it off so it can eat the flesh.
The marsupial lion was not all that big, about 1.5 meters long and less than 160 kilograms. But it was an agile and crafty animal, the tactical killer of its time. Its sharp claws made it an excellent tree climber. It made up for its lack of size by launching attacks from the air, taking its prey by surprise. A tactic which has given it the nickname Drop Cat.
The marsupial lion was absolutely built to get in and close up and personal with big, dangerous animals and fight those animals and wrestle those animals to the ground.
And the beast had a phenomenally strong bite.
Pound for pound, it had the most powerful bite force of any animal that's ever lived.
This is the skull of the marsupial lion. And basically it's got the most unusual teeth of any mammalian carnivore. And they would have worked in unison to clamp around the windpipe of its prey. Something like this.
These front incisor teeth were used for holding or potentially suffocating the prey, and then these large blade-like premolar teeth were used to slice off pieces of flesh.
All of these tools combined to make the marsupial lion a lethal opponent, the only creature able to challenge Megalania. These predators would have generally avoided each other, but they hunted the same prey, and their world was changing.
The Pleistocene itself was a tough time. It was a time that was dominated by what we call glacial and interglacial cycles, culminating in the last glacial cycle, or the last ice age, that was drier, and we had more super droughts than any other time previously.
As Australia became more arid and food more scarce, it's possible that the monster mammal and giant reptile would find themselves competing for prey.
So we can imagine a scenario where Megalania has come into the marsupial lion's territory. It's looking down, it sees the giant lizard and perceives it as a threat, and then attacks by leaping down onto the lizard. Once the marsupial lion was down on top of the lizard, it would probably go for the neck. You would not want to take your eyes off the head of Megalania.
It would be a brutal battle between two gladiators. Even Megalania would be vulnerable to the lion's death grip on its throat, but it had other ways to defend itself.
But Megalania had another weapon. It had a flicking tail, so the marsupial lion would have to watch out because a flick from that tail could cause a serious injury.
If I was a betting person, I'd probably put my money on Megalania. All Megalania has to do is get a bite in, and the marsupial lion's in serious trouble. The marsupial lion, as powerful it was and as effective predator as it was really outclassed by the size and manoeuvrability of Megalania.
Megalania's sheer size would ultimately win the day. But in Ice Age Australia, even the prey animals, such as the mighty Diprotodon, were dangerous. How could a lizard, even a giant lizard, tackle a behemoth like this? Some scientists believe that the giant ripper had a secret weapon. Australia today is renowned for its cute, quirky, and mostly small creatures. But less than 70,000 years ago, it was a land of monsters. The top predator was the giant lizard called Megalania, a 6-meter-long mega monster known as the Giant Ripper. But the biggest beast in the bush was Diprotodon, a plant-eating mammal the size of a rhinoceros.
We're looking at the world's largest marsupial ever, an absolute monster. Now, an animal like that has no natural predators.
Diprotodon probably wasn't a very nice animal. It was mean, and it was large, and it would be something that all animals, I think, would avoid.
At 2,700 kilograms, Diprotodon outweighed Megalania 10-1. Could the killer lizard have brought down this walking mountain of meat?
Megalania would have found adult Diprotodons inherently difficult to tackle. The sheer size of Diprotodon in and of itself would have been a very effective defence against predators, including Megalania.
But evidence is growing that Megalania had a secret weapon that would have allowed it to tackle literally anything, including these giant marsupials. Once again, the living monitor lizard offers clues to the past. The Komodo dragon regularly hunts animals far larger than itself. It has been known to kill water buffalo 10 times its own weight. It's long been thought that the Komodo dragon has a sort of deadly drool full of infectious bacteria that lives on rotting meat in its gums. But Brian Fry believes it is a myth.
The problem with the toxic bacteria theory was that it's based entirely on an absence of evidence. There's no evidence for this. The one study that looked at the bacteria found pretty much the same bog standard bacteria you'd find in the mouth of a kindergartner, a lion, or in the intestinal tract of one of their prey items. There's nothing unique in there. There's no super toxic bacteria.
Brian Fry thought there might be another explanation for the Komodo's deadly bite.
The first thing we noticed when we started working with these animals is a huge bulge running the length of the lower jaw on either side. But if you go into the reptile anatomy books, it's not in there. There's nothing in the anatomy books talking about that, even though this is a massive bulge. This is not a trivial structure. And that got me thinking immediately, because this is the exact same location where you find the venom gland of the American Gila monster or the Mexican beaded lizard, thought to be the only venomous lizards in the world. But they're also very close relatives of the monitor lizards. So it was not inconceivable that this bulge was the same gland as the Gila monster, and therefore they may be producing the same venom.
Eventually, Fry found a way to prove his theory, using the preserved head of a very rare Komodo dragon.
What I have here is a real Komodo dragon head. This is a zoo animal that was captive bred that died, that we were then allowed the opportunity to use for our research.
Fry and his team scanned the head using MRI technology.
With the magnetic resonance imaging technology, we're able to go from a preserved head like this into computer data where we now have everything rendered in 3 dimensions. And what that means is that we can examine what's happening on the inside. So here we have the 2 eyes, the grey is the tongue there, the long tongue that you see coming out. And then we have showing here 2 sets of glands on either side.
The lower set of glands on each side produces venom. Fry has discovered that the Komodo dragon isn't the only monitor lizard with this type of venom gland.
We've looked at monitor lizards now from everywhere where they occur. Africa, Asia, and Australia. We've also looked at all different kinds of species, whether it be the ones that live in the trees, the ones on the ground, and even the aquatic ones. They all have the same generalized gland, and they all have very similar venom.
Snakes have powerful muscles specifically for injecting their venom through hypodermic-like fangs. Monitor lizards, however, don't have the ability to inject their poison. Instead, they rely on a different method. When the Komodo bites its prey, the pressure forces venom from the glands into its mouth where it mixes with saliva. The toxic brew then oozes into the wound. If modern monitor lizards have venom glands, is it likely that Megalania also would have the ability to produce toxins?
Megalania was basically just a supercharged lace monitor. That would be the closest relative of it. Now, the closest relative of the lace monitor is the Komodo dragon. And we've studied the venom in both the lace monitor and the Komodo dragon. So if you have an animal with very similar anatomical features, it should logically possess the same venom glands. All of this strongly suggests that Megalania was the largest venomous animal to have ever lived.
If Fry is correct, this venom gland might have been the secret weapon that gave Megalania the power to bring down huge prey animals and even compete with other predators. No matter how it killed, for hundreds of thousands of years, Megalania was the undisputed mega-monster of its world. But around 50,000 years ago, a new predator arrived on the scene. The first humans to arrive on the continent found that Australia was a hunter's jackpot. The land that Aussies called the Lucky Country teemed with an endless bounty of edible beasts. But those early Australians may not have been the only predators after the abundant prey. Megalania, the giant ripper, had dominated the land. Did those early human beings ever cross paths with this monster lizard? Most scientists believe humans migrated to Australia from Asia or Africa around 50,000 years ago. Is it likely that Megalania was still alive at this time? To answer this question, we must determine the age of the youngest Megalania fossils. Until now, there was no way to do this with any degree of certainty. The well-known carbon-14 dating method can only be used on fossils up to 40,000 years old, much later than the arrival of the first humans. But this machine allows us to extend our ability to date fossils much further into the past. It's called the TIMS, the Thermal Ionization Mass Spectrometer.
Now that allows us to push the dating limit back to somewhere between 500 and 600,000 years, so, you know, long way outside of that radiocarbon dating barrier.
Dr. Price ran 10 samples taken from Megalania teeth through the TIMS. Price is still reviewing his findings, but the preliminary results indicate that Megalania may well have been alive 50,000 years ago, around the time humans arrived on the continent.
We've got some exciting new data that's starting to come out, based not only on direct fossil evidence, but also on the dating as well. And it's starting to suggest that we do have a time overlap between the last of the megafauna, specifically animals like Megalania, and some of the first human colonisers that entered Australia.
If this is true, Dr. Price's research could rewrite the history of prehistoric Australia. If humans and Megalania did live in Australia at the same time, they could have encountered each other. What then? How effective would the primitive weapons of the first Australians have been against a venomous giant lizard 6 meters long?
This is a fire-hardened tip on the end of a spear. This is the sort of spear that people would have used in the Pleistocene. This, in fact, is made out of mulga. It's heavy, it's very strong, it would be very difficult to break. And it's the sort of spear that's needed for thrusting. And you'd have people either side jabbing with similar weapons to distract it. But even with all this happening, this is not really a weapon that would really help you against Megalania.
Running from Megalania wasn't an option either. Like all monitor lizards, this creature was remarkably fast.
The speed with which Komodo dragons can run, for example, they can run up a hill faster than I can run down it. A 100-pound human being would not have stood a chance against a 20-foot-long Megalania or even a 12-foot-long Megalania. It would have been lunch.
Megalania was Australia's alpha predator for at least 500,000 years.
A big Megalania would have no natural predators. There would have been nothing alive at that point in time that could have taken it out.
Yet this giant lizard, which had ruled a continent, eventually died out. It disappeared, leaving only a few fossilized bones to mark its legacy. How could such a megabeast vanish without a trace?
Many people think that extinction is an instant process, something that occurs overnight. But extinction is a very complicated process, and it usually happens over thousands and thousands of years.
We don't know why Megalania became extinct. It could have been because of climate change, or it could be because of human hunting, or perhaps a combination of both. The fact is, all the megafauna in Australia became extinct, Megalania amongst them.
Despite the occasional rumours that Megalania is still lurking in the Australian outback, paleontologists have no doubt that the giant lizard is long gone. It would seem that the age-old rivalry between reptiles and mammals has been settled. But there are still plenty of Megalania's relatives alive today. The monstrous Komodo dragon can reach a length of 3 meters and has been known to kill people. Humans have been around for about 200,000 years, but monitor lizards have survived for 60 million years. There's no question that these cold-blooded killers are quite capable of making a comeback.
If humans were to go extinct, it's pretty easy to imagine that a giant monitor lizard would again evolve from in the Australian environment. All it would need is for the top predator, the humans, to go away, and they'd be back as dominant predators. Same size as Megalania, maybe bigger.